Blazor Train.
Steve Sanderson, it's my pleasure to have you back on Blazor Train. And wow, what a whirlwind couple of weeks for you with this announcement.
Yeah. It's gone very well. People have been very excited, and we're all looking forward to seeing what we can do.
Yeah, the response has been amazing, and it sort of blew my mind. You know, I didn't expect it. I mean, I kind of expected some move forward, but I didn't expect such a dramatic change, and it sounds great. So to remind the viewers what we're talking about here, it's Blazor United, and I will post the links to the existing demos because we're not going to do a demo here. What we're going to do is a little clarification. I have some questions, and hopefully that will just help solidify in everybody's mind what's going on here. So I'm going to start with too long don't read summary that I got from the community stand-up. So Blazor Unified has these 5 features. So server-side rendering with Blazor components, streaming rendering, enhanced navigations and form posts, combining components and pages with Blazor Server or Blazor WASM in the same app, right? And auto switching for a component or a page between server and WASM. In other words, let the system decide, start with server, end up with WASM, let it figure out how to do all the details. Did I miss anything?
No, that's all absolutely true. We could probably even give a more high-level statement of what we're trying to achieve here, which is we're trying to take Blazor as a programming model and make it applicable to the full spectrum of web UI scenarios. So today, Blazor is oriented around SPA-type scenarios where you've got a stateful interactive UI. That's what it's always been about from the beginning. But of course, that's not the only kind of web UI that people create. They also create largely static server-rendered HTML pages, which have historically been only available with a different technology, not Blazor.
Right.
That's all right, but Blazor is the most modern and powerful web UI system that we create in the ASP.NET team, and so wouldn't it be nice to use that same technology for server-rendered HTML as well? Then developers only need to know one programming model, and it can span both your static rendering and interactive rendering. So that's one of the biggest high-level ideas, and then all the things that you listed, those are really important parts of making that enabled.
So let's talk about that static rendering. So it seems like MVC and Blazor are kind of dating. Are they not? Are they married? Are they having a child here? And I guess that means that the static server-side rendering with Blazor components, are they taking the job of Razor components that emit static code? Are they the same thing?
Yeah, so it's a good question. So in many ways, we do want Blazor to be an alternative to Razor Pages as a way of producing your server-rendered HTML. Now, it doesn't mean that we're not interested in Razor Pages anymore. It's a perfectly good programming model. People are using it. They're happy with it. That's great. But we want to allow the option to use the component-oriented programming model that Blazor gives you, which is potentially a little bit more powerful, a little bit more easy to use.
Right.
And one of the key points here is that it's not just to throw away your existing site and create new stuff from scratch.
Yeah.
It's designed to work together. So people can take an existing application, which is full of a mixture of Razor Pages and MVC views or whatever else, and start adding some Blazor component endpoints and simply use them as part of an existing site. And then over time, you could do more and more of that. You could maybe switch over to that completely, or you could have a mixture forever, whatever suits you best.
Okay, that's good to know. That was one of the questions that our guys had, and we'll get to some more in detail. Let's talk about streaming rendering. So streaming rendering is when, correct me if I'm wrong, from what I understand, if you render HTML JavaScript, whatever it is, on the server side. And instead of the page waiting for all of that stuff to show up, it comes down as it comes down. You have like a static section of a page, let's say, and then some components are going to initialize, and you get that little loading button. And we do that now. But I guess, how does that actually work?
Yeah. All right. So in some ways, this is about bringing one of the benefits of SPA type programming, but to server rendering. So imagine that you've got some database backend that is going to do long running queries. Like maybe there's some sort of like search that you can do, and it takes like 5 seconds or 10 seconds for this thing to return. Or it's an API call that you don't control, whatever it is. With a SPA type rendered site, normally the initial skeleton of the HTML page goes down to the browser immediately without waiting for that. And then the query starts up, the UI displays loading or something like that. And eventually it gets filled in and the user knows what's going on. But with server rendering, traditionally, the server is just waiting for that database query to complete or API call to complete until it's able, and until that happens, it can't return the page. There is a kind of streaming rendering supported with MVC or Razor Pages today. Inside Razor Pages, you can use the async keyword or await in certain places, and that will pause rendering while things like database queries complete. But it's quite limited because it interrupts the entire response. So, maybe if you want to do something asynchronously to find out what the page title is, well, if the page title is at the top of the HTML page, well, everything has to wait. So you can't render anything until the query completes. So what streaming rendering does, or what we mean by it in this case, is that we can return the outline of the whole HTML page right down to the closing HTML tag without waiting for async operations. And then we can, after those complete, we can send further markup to the browser after the closing HTML tag to tell it to fill in different parts of the page. So yeah, that gives you that SPA type experience. Now, you asked how it actually works. So I guess we could achieve this in many different ways. We've created a prototype of it. The way it works in the prototype is that for each of the components that you've rendered into your page, we inject little marker tags around it, HTML comments that indicate where the start and end point of each component is. And then on the server, we know which components are still rendering because Blazor's existing renderer keeps track of all that stuff. And when each component sends further updates to the render output, we can send a little bit of extra content to the HTTP response stream saying things like, for component 15, replace it with the following markup. And so then we just have to send the markup for that one part of the page, and then on the browser, we can patch that into the DOM at the corresponding location in the page. And we're not limited to just doing that for one component. We can do it for many. And theoretically, you can even have a component that sends any number of streaming updates. You could make, if you were utterly insane, you could create like a clock component that every second sends an update to the time and just keeps doing it forever. And then even with server rendering, you'd have a clock that keeps updating. You obviously shouldn't do that because your response will never end. But I'm just illustrating that it could be done.
Sure. Okay, so it seems like this is something that I've programmed in Blazor before. You have a Blazor component, and the whole page renders, and then the Blazor component hooks its uninitialized async or whatever, and then it goes and gets some data and displays a loading GIF or whatever, and then implements itself. But I guess, so this feature isn't really all that new in theory to Blazor developers, but more for static web developers. Isn't that right?
That's 100% right. In fact, we worked to retain the existing Blazor programming model around loading. So if you've already got Blazor components that go through a loading phase, then they should just automatically start working with streaming rendering. There are no new APIs, no new patterns to know about.
Right. So here's a question from one of the guys. How, if I have a component, right? If I've built a component that my team is using, right? and they're going to use auto mode. I guess there's a render mode property in the component model now.
Yep.
Can I just inspect that and say, oh, if it's auto, now how do I check whether or not it's running as a server component or a client component so I can call an API if it's running on the client, or call a service if it's not? Do I even do that? Should I do that? Where should that decision go in my architecture?
Yeah, that's an interesting question. I don't think we've necessarily fully worked out all the details on that. A lot of this stuff is, early stages of prototyping, and we're still figuring out what patterns people will use. But there is kind of prior art for this, because Blazor already, in .NET 7 and before, already pre-renders on the server, renders interactively on the server, or renders interactively on WebAssembly. So all the rendering modes already exist. The new part is, making everything work all simultaneously and mix and match within the same project. So if you've already got a component that knows what to do when it's being pre-rendered and knows what to do when it's running on Blazor server and so on, and many people do write components that work like that, then it will just automatically work in the right way in each place. So the common pattern that we recommend is that if you're going to do things like JavaScript interop, you don't do it until the onAfterRender method, because that's the point at which the DOM exists and has been hooked up. And so for server rendering, pre-rendering, the way that already works is that we simply never call that method because there's never a DOM on the server. And that will be the same for Blazor United server rendering. So you just can't do JS interop because there's no JavaScript.
Right. All right. So, it's kind of, I guess what we're saying is, for now, you can always just write your code to call APIs, put an API layer in there. If eventually you're going to end up on the server in auto mode, on the client, just write an API layer. And if you're on the server, you can call it. If you're on the client, you can call it. And Bob's your
this is interesting. Maybe you meant something slightly different than I thought. So are you referring to data loading scenarios? You want to get data out of like your database or API endpoint? Right.
If it was a Blazor server app, I'd just call a service.
Yeah.
Yeah.
Okay. Yeah. So that's a whole other area of interest in exploration. So like you just said, one way you can always solve it is just write your own abstraction, like create some interface to represent your API, and then you'd have a server implementation and a WebAssembly implementation, and it's going to do the right one. And if anyone's seen the demo videos that we've made about this with the Best For You sample app, that's precisely what that does. It's got a submit recipe page. When you submit a recipe, there's some interface that describes that action, and that uses DI to pick the right implementation, and then, it does the right thing. So that's the manual solution. Longer term, it would be really interesting to try and create some more automatic way of doing this. We've had lots of thoughts about that. We've even had meetings and brainstorming about what could we do to make this better. And there are some difficult trade-offs. One possibility that we could do that I'm leaning towards is some method for annotating a server-side service to say that I want to automatically generate at compile time an interface representing this service so that I can inject it into my components, and then when it's running on WebAssembly, it can automatically do HTTP calls.
Kind of like what gRPC does.
Yeah, very much like that. In fact, gRPC is one of the sort of starting points that we've taken to understand what to do with this.
That's done really well.
Yeah. The hard part about designing something like that is dealing with things to do with performance and security in edge cases. So imagine we make this brilliant magical system that allows you to call your server-side APIs really easily through auto-generated HTTP client calls. Well, that's great, except that then people might just forget about the fact that they're exposing these arbitrary bits of server-side code to the browser.
Unless it allowed you to make DTOs specifically from your models that said, hide this field.
That's right. Yeah. Yeah. And you've kind of got two completely conflicting goals. Like one, you want to make it as easy as possible to call these methods, but two, you can't afford to make it easy to call these methods because then people just will. And unless by default everything's locked down, then people will make mistakes.
Yeah. All right. This is great, by the way. I'm so excited. Let's talk about circuits, SignalR circuits. So, yeah, I mean, I guess one of the issues, it's not a problem, but it happens, right? If you have a Blazor server application, you don't tweak it correctly and you don't set up the timeouts and whatever, you go to a tab and then you come back to it and you've got this white screen and it says, your circuit is disconnected. So how is Blazor United going to help that scenario?
Well, the main thing it helps with is it recommends a different architectural pattern where you're not so dependent on statefulness. So, and this is not something we're just inventing. This is a pattern that we see across the industry. There's lots of different frameworks that have started adopting this kind of architectural philosophy. And one of the main ones to look at would be Next.js. And I think we'll end up with very similar recommendations to what they do, which is that by default, you should hope to try and make most of the pages in your site stateless and just implemented through server rendering. And those kinds of pages are very cheap for you to deliver. They don't depend on the user having any long-running connection to the server or any WebAssembly. And it's impossible to become disconnected because you weren't connected in the first place. The more you can implement like that, the more lightweight and resilient your site is. When you do need to introduce server components, then at that point, for those things, you are dependent on some level of ongoing connection. But the hope is that you won't end up in the situation so often that there's lots of long-running state that you can't afford to lose.
Right.
And so if it does have to reload the page, hopefully it's not such a big problem for them. We are looking at a couple of ways of potentially giving you extra ways to store state so that if the connection is lost, it can be brought back. However, that's never going to be automatic. People kind of have this idea quite often that, we should just automatically preserve all the state within a circuit. But unfortunately, .NET just doesn't work like that. Things are not serializable by default. We can't serialize things like arbitrary delegates or just any object from your domain model. We can give hooks to developers to let them serialize it, but people don't want to. That's huge amounts of work and it's very error prone as well. So
when you say state, you're talking about the circuit state. I can still have a scoped service in my app on the server side that even though there isn't a circuit, it still maps accordingly to that user, right? Because am I saying this the right way? Or are you talking about all state, even state that I keep per user? We should be not using that.
All right, well, let's use a couple of examples then. So one would be, imagine you're implementing something like a document editor, or I don't know, the world's biggest form that's got 10,000 fields in it.
I've filled out that form.
Right, yeah. So the user's going to spend a lot of time on this page, and the state that they enter into it is really important to them. They're going to be super mad if they get 3/4 of the way through of whatever their multi-hour job is, and then you go, "Oh, sorry, disconnected." Reload the page. In that kind of situation, it's a very constrained world where you know what state is important. It's the document or it's the form, and as a developer, you probably can be. It's practical for you to manually serialize all that stuff.
Yeah.
So we could intermittently send it all down to the browser, or we can intermittently dump it into a server-side database.
Yeah, or even on the client side, right? I mean, if it's not critical, if you're not putting in your social security number or something, you could save that in browser storage or local storage.
You absolutely can, yeah. So for these kinds of well-bounded scenarios, it's believable that we could create APIs that let people solve this problem for themselves. But there's a much more general scenario, which is, can we just save the state of literally everything? Every component that's in the component hierarchy, every single parameter that's been passed, all of these arbitrary objects that are referenced from anywhere, that might even refer to objects on the heap that are also used by other people. Maybe you've got some other state management system that spans users and you're referencing that. just literally everything? Can we just save it all? Well, the answer is no, because, it would end up in the worst case being like we have to serialize the entire .NET object heap, like the potentially gigabytes, and there's no boundary between different user state and things like that. So no is the answer. We can't just save it all.
Yeah. Okay. So what you're saying, what you're proposing here in Blazor United then is static first. Everything that can be static should be static.
Yep.
You shouldn't have to have a component that emits static HTML. That should just be out there. And then you dot your app with components or pages that implement...
Well, just to be clear, the static HTML is components too. It's just that it's running in a render mode that's not stateful.
Yeah. Okay, good. Yeah, very good. So then you can dot your application with pages or just individual components that implement the different hosting models. So one component can be WebAssembly. That means when they go to that page, if the WebAssembly DLLs aren't downloaded, they'll be downloaded.
Yep.
And then others can be server-side rendered on the same page.
Yep, that's right. Yep.
Yeah. And so then the auto thing becomes very interesting for most. Do you anticipate that most people will use the auto mode, and why would they, right?
Okay, so just in case anyone's unfamiliar, the auto concept is simply that you're saying that your component can run either server-side or WebAssembly, and it's up to the system to pick. And one obvious rule that we could use, and maybe we make this more controllable, but one option is we say, has this user already downloaded all the WebAssembly files? If so, we'll use that, because then you don't have to pay for server resources. But if they haven't downloaded it yet, then we'll use Blazor Server while they're downloading in the background. So that's the auto concept. And as for your question, will everybody use that? Should everybody use that? I don't think we really know the answer to that yet. I feel a bit torn about it because on one hand, I know that it comes across really well in a demo. So if you're trying to demonstrate Blazor and you go, look, we do this cool magic thing, isn't it great? Everyone's like, yeah, that's what I've always wanted. But at the same time, you have to remember that if you are going to do that, you're now promising that you are willing to incur the costs of holding the circuit open for any user that wants it, and you're willing to incur the extra development effort of supporting WebAssembly, which means you can't just call arbitrary server-side code anytime you feel like it. You have to go through APIs. So there's non-trivial drawbacks to supporting that mode. So for what scenarios do you really get a high payoff? Well, if you're creating a business-specific application that's only ever used by people who work for that business, and 90% of the time they're sitting at a desk with a laptop on a fast network, and there's never more than 10,000 of them, then at that point, the existing render modes are actually quite good. WebAssembly, you don't have to worry about the download time because they've got a fast network anyway, and they're only doing it once a day.
Unless they have antivirus. But that's another story.
Well, actually, we do have hopefully a solution to that, but we can come back to that.
Okay.
And then server, that's pretty good for them as well because, there's only 1,000 of them or so, maybe 10,000, whatever. So one server is going to be able to handle that, and it's not going to cost you an unlimited amount of money. So, why would you want to incur the extra complexity of saying that you don't know which render mode something's going to be in? Probably not in that scenario. But maybe there's other scenarios, like one that does occur to me that probably is compelling would be something like a software as a service type public site where you don't know how many users you're going to have.
Right.
Like maybe it's 100 today, but maybe you get into the news and you've got 100,000 tomorrow. You want to be ready for large amounts of traffic.
Yeah.
And your users might be on spotty network connections. At that point, it is quite appealing to say, yes, we can automatically adapt within the context of each user to things like their network conditions, potentially the speed of the device that they're running on.
Right.
And, you could even do some sort of scaling thing where you say, I don't know, depending on how many servers we've got available will change between how we balance people. I don't know really, but having that level of flexibility becomes very appealing.
So I hear what you're saying. Are you saying that the programmer can decide when to change rendering modes?
Well, in our prototype, there's just a single rule, which is, have you got the WebAssembly files downloaded? But several people have pointed out that they would want to have more complex control over that. They might want to have some rule like, well, a really basic and obvious one would be, does this browser support WebAssembly?
Right.
Like 99.999% of the time, the answer is yes, but it's just an extra if test for us. We can just put that rule in.
So I guess the constraint that you'd want to add would be after, at the point where auto mode would switch from server to WASM, maybe I, as the programmer, want an event or a hook or something, so then I can further decide whether or not I really want this to change.
Yeah, that's right. So maybe, for example, you've got, in certain scenarios, you might know that people use really, really low-end devices like a, $30 Android phone from 10 years ago. And you might say, for those people, I just never want them to use WebAssembly because the performance won't be good enough. So you put in some rule about that. Or maybe somehow that your staff occasionally work at certain locations where the network can't be relied upon. And so you never want them to use server in that case.
Yeah. So we can figure out if we're on mobile by using JavaScript interrupt. I don't know. I've never thought about querying the system for available memory. Is that something we can do in WebAssembly?
You can absolutely do that. Yep. So JavaScript has got the performance APIs that give you all kinds of details about that kind of thing.
Oh, excellent. Excellent. And somebody mentioned in the community stand-up, and I don't remember if you answered it or not, or you guys did, if only some components are WASM renders, does that mean we can trim down the .NET WASM.js file and all the, how does trimming work in this new world of Blazor United?
Yeah, well, in all cases, it works the same as it does today. So we're not changing the trimmer. What we would be changing would be the ability. So we're looking at a new thing, which is the ability to have a single project that builds for both server and WebAssembly from the same project. And that's purely for developer convenience. It doesn't fundamentally let you do anything new. It just means you don't spend as much time thinking which project should my file go in. So if we do that, and we are planning to do that, then you would want some way of controlling which files are included in which compilation. So maybe by default, CS files are in both compilations, but for certain ones, you want to say this is only going to be used on the server, this is only going to be used on WebAssembly. And then if you've got some dependency that is only ever used on the server and therefore isn't included in the WebAssembly compilation, then the trimmer will not encounter it, and therefore it will automatically strip out anything that is not referenced within that compilation.
Yeah, that's how I expect it would work. That's great. So I'm a third-party developer, right? Mm-hmm. I'm a big software tool company, and I have lots of customers, and they have my tools. Do I have to do anything in particular to support this, the render mode, or do my developers? I mean, it sounds like the developers, when they instantiate a component, say, here's where the render mode is. It's, server, client, or auto. Do I have to do anything in particular to support that?
So people creating component libraries can, if they want to, impose some sort of constraint over the render mode that they run in. Like maybe you're creating a component that's like, I don't know, some sort of like graphical designer where the user builds diagrams with boxes and arrows and stuff that. That's obviously never going to work with a plain server rendering. You do need interactivity. So maybe you're going to mark that component as being auto render mode or something, which means that it will, I don't know, maybe we should have a new rendering mode, which is like an unspecified interactive mode, which is saying that the person who consumes this component needs to have specified a render mode, which is either server, WebAssembly, or auto. And I'm just going to throw if they didn't do that. That would be a possibility. But my hope is that for most components in class libraries, people will not express any render mode preferences. They'll just say, wherever you render this, I'll just accept whatever render mode you give to me, and I'll do the best I can. So if you're building a component that doesn't strictly rely on things like event handlers, then there's literally nothing you have to do. Just your component as it is just going to work with server-side passive rendering. If your component does rely on things like event handlers, at that point, you've got a decision to make. You could say, all right, I'm not going to take any action. The developer who uses this just has to understand that if they fail to give me interactivity, then I just won't be interactive. And, maybe they've got a legit use case for rendering in just a static mode, and that's good enough for their scenario, that's fine. Or maybe if you want to be super advanced, and I hope people don't try and do this in every case because it would be a mess, but what they could do is try and think about how can I restructure the behavior of my component so that it maps to native HTML behaviors. So if you can structure the behavior of your component to use, say, regular HTML links for things, then maybe that will work even in a non-interactive scenario. So for example, a grid, like I made this quick grid component last year, which we're putting into the product now. I would hope and expect that we will update the pagination part of that so that it will do something with hash or a query string or something, so that even if you don't have any interactivity, it can still navigate to different pages.
Yeah. Default behavior. Yeah. All right. Authentication authorization is a moving target, and I know you love to talk about this. Developers hate auth, don't they? It's just like the last thing on the mind of a developer is, oh, geez, I got to lock this down.
It's just losing in every way.
Yeah, absolutely.
The absolute best case is that nothing bad happens. And every other case is much worse than that.
Yes. So does this change the authentication architecture of WASM apps or auto mode? Do we have to worry about that?
Well, we don't, as yet, have any specific plan that anything will be dramatically different. So it might be that we can find ways of improving and making this more streamlined than it is today. But if we do nothing for auth, then the same patterns that already exist for WebAssembly and server would continue to exist. So that's kind of the default outcome at this point. But, we are open to people's ideas about how this could be made more streamlined.
Well, I know I've done MSAL authentication in Blazor Server and in Blazor WebAssembly, and the way that we do that is different.
Right.
It requires different methodologies. I mean, if you're on the server, it becomes a little bit easier. If you're on the client, I guess we're falling back to that idea of code as if you're going to be WebAssembly, right?
It depends. So if you ever want to run in a scenario where you can't rely on any particular backend server, like you want to create an application that you deploy to a static web server, like GitHub Pages or Azure Static Web Apps or something like that. In that case, you can't rely on any particular server. You have to manage all of the auth entirely in the client, and you have to deal with the full complexity of SPA type authentication, which you're describing there.
Yeah.
But if you can rely on there being a particular backend server, which is generally going to be the case for this kind of architecture we're talking about on Blazor United, then you can instead think of it with the backend for front-end pattern, where you say, okay, this front-end always has this particular backend. The backend can manage the auth, and then the front-end, and then the browser and the server can just deal with cookies in a traditional way. So the server always knows who the user is, and then it can deal with auth in a server-oriented way.
So you do it the way you would do it with a hosted Blazor WebAssembly application in .NET 7.
You certainly could do that. That should just work, yeah.
Yeah. All right. That's great. SEO, pre-rendering.
Yep.
Any changes here anything better for SEO? I mean, one thing I know about SEO, or pre-rendering anyway, is that those lifecycle events tend to get hit twice, a few of them, because once for the pre-render anything changing here?
Well, they will only be hit twice when you're pre-rendering and then a user is a real user rather than a crawler who, was just wanted the initial HTML. And that is not likely to change. It might change. We've got a possible idea for how we can keep the state of a circuit going so that it spans the server rendering and the interactive rendering. But we did implement that once already, and then we had to revert it because there were potential issues with security on that. So, yeah, I mean, I probably wouldn't worry too much about the lifecycle running twice thing. If the concern is that you have to fetch data twice, there is a solution for that. Yeah. But in terms of the more general questions, anything that does server rendering will just naturally have an easier time with SEO because there's less for you to think about with the, how much of my script is this crawler actually going to run? Can I guarantee that it really runs? So the more server rendered you are, the easier life is for you in that way. The only thing that's really fundamentally potentially different here is the streaming rendering. If you do streaming rendering, then at that point you are reliant on the crawler running your script in order to insert these extra pieces of content after the initial HTML markup. So what we might well do is have some kind of default where the streaming rendering doesn't run for things that look like a crawler, or maybe it only does run for things that look not like a crawler, depending on which way around we implement it.
Okay, getting back to circuits. Let's say I have Blazor United, some static content, and I want to put a little server component, server rendered component on the page, but only on one page.
Yep.
If I leave that page, does that circuit just go away and I don't have any more dependencies on circuits?
That's very much the intention, yeah. We haven't implemented that in our prototype yet. Right now, as soon as you get a circuit, it stays there until, you close your browser tab or whatever. But the intention is that circuits will appear and disappear as a user navigates around. And that really ties into this idea that we're trying to minimize the costs of what you're doing at every stage. You should only incur the costs of a circuit when it's strictly needed for what the user is doing at this moment. And also it gives you more statelessness. As you mentioned before, the more state you rely on, the worse things are if the user disconnects. Whereas if that circuit is only there briefly, depending on what the user's doing, less chance that you've got a problem.
All right. Okay. Very good. One of my guys says, I've got a project that we're gradually migrating from MVC to Blazor, and there's also an Azure Functions project in there. Getting shared code to behave across all these platforms can be high friction, especially around configuration and context. It strikes me that this might introduce more complexity. For instance, I'm pretty sure WASM supports HTTP context today, but server does not. Is there a plan to make sure we aren't adding more rough edges?
Okay. Well, it's the other way around. I think I imagine that was a typo. So server does support HTTP context and WebAssembly does not.
That makes sense to me too. Yeah.
But as for including more friction, obviously it's not our goal. If there are particular points of concern, then we'd love to talk about that. It's because we're still at an early design stage and things can change. For HTTP context in particular, certainly one of our goals would be not to be exposing HTTP context directly due to that sort of inconsistency there. So we will try to help people write code that's more platform agnostic. But yeah, we're still figuring this out.
All right. Another thing is when Blazor first came on the scene, you being Microsoft, did some testing around Blazor server and, how much memory per user it used. And therefore, when latency for a button click went over 100 milliseconds, you said, okay, well, this is the number of users it can support. And I believe it was like 3.5 gigs of RAM could support 5,000 users comfortably and whatever. Have any new tests been done for that?
I think that we have ongoing benchmarking for this, but I don't have any numbers in my head. And I don't recall us really talking about it either as a community or as a team anytime recently. So I doubt that anything significantly has changed. .NET itself generally gets a little bit more performant on every release, so it's probably better than it was a couple of years ago. But yeah, it's not a thing that we've had recent discussions about. One thing I would say, though, is that there's been very, very few cases in the 3 years or something that we've... How long is it? 3 years since Blazor servers came out? That that people have said, oh, my server is just like can't handle the load. Like, it's just really, really unusual for people to struggle with that.
And .NET has got more performant and less memory footprint too, hasn't it?
Yeah, it should. In general, yeah. There's a lot of smart people doing good work in every release for that.
Yeah, including you, sir. Live updates. So if people are using my application and I want to publish a new version, obviously it's going to clobber state, and it's going to show another reason to be as stateless as possible.
Yep.
The way that I handled those in WASM was different than the way I handled it in server. Server, I actually looked for that, whatever it is, the reload button, the reload link, and then pressed it automatically in JavaScript. But is there a new way to handle that or think about how to do updates?
We don't have any plans for a new feature around that. As you've correctly pointed out, stateless pages don't care either way. There's no problem there. WebAssembly largely doesn't care. You could change your APIs and then the app that's running in someone's browser is no longer compatible with the newly deployed APIs, but that's literally true for every single SPA technology and for native mobile apps and like millions of things. So, there's nothing unique there. Blazor Server is the more unique one in that it relies on this continuous connection. But I don't think it's any different from any case where the user loses their network connection. So if you've got some kind of UI pattern around that, then it should handle the same thing.
And it also it should encourage you then not to have a page with 100 individually Blazor server rendered components on it, because you got 100 circuits there, don't you? Or is it going to share circuits?
No, they do share circuits.
Oh, God, thank God for that.
There'll always be either 0 or 1 circuit at any given time. When a component comes along, we can check, is there a circuit already? If yes, we'll join it. If not, and then it's effectively like a reference counting thing. When the last component goes away, we can then shut down your circuit.
All right, so it really isn't any different. I mean, if you'll still get that page if you've got a circuit open. Yep. You're still going to get that thing. So we'll just carry on doing it the same way. But it's also another good reason to use auto mode, isn't it?
I guess it gives you a lot more flexibility to change how stuff works.
Use the circuits until you don't need them anymore.
Yeah. Yep.
And speaking of downloading DLLs, we talked about this antivirus issue. I mean, some people, if they have certain antivirus programs that block the DLLs for WebAssembly.
Yep.
You said you had some ideas around that.
Yeah. Well, firstly, I would say that this has been incredibly uncommon. Like that, we've had probably a total of, I don't know, like about 5 people who have, given us clear detail about having encountered this.
Okay.
And it's certainly a concern in those cases, but it's not been a very widespread thing
good.
Because we're just using web standard technology. There's literally no reason why anything would be blocked. It's not even possible to do something dangerous in WebAssembly. But you are absolutely right that sometimes people have configured their like corporate firewalls in a perhaps overzealously risk-averse manner, where files are blocked based on their name, despite the fact that there's literally no way that they can contain anything dangerous. Or in some cases, based on patterns of data inside those files that, again, still can't do anything dangerous.
So it's really up to the antivirus software manufacturers to say, hey, this is going to run in WebAssembly.
Well, and not just like, they shouldn't just say, oh, we trust that it will be used in WebAssembly, because of course they're all about not trusting.
Of course.
And they're right to not trust. Yeah. And it should be more about, like, based on where this file, based on the fact that this is inside a browser, we know that it can't do anything dangerous. No matter how much the person delivering it wants it to do something dangerous, it just can't. And that's hopefully the basis that they would be understanding this on. However, despite us explaining this to a whole bunch of people still do have issues. And so the bigger solution that we are hopefully bringing into .NET 8 is a different file format for the assembly bundles that are coming out of the build system. This is, if people want to look up the details, they can search on GitHub or whatever for WebCil, WebCIL. And that's because CIL is another name for the .NET instruction language. So, that's why the name comes from. And it's a different way of representing the instructions that has no relationship at all to an executable file. So one of the
So it's not a DLL that's renamed.
Yeah, that's right. Okay. Yeah. If you just rename a DLL, then, it's still a DLL.
Yeah.
And if you look at the file header, you can see that it's a DLL. And in many cases, that's the sort of thing that people are getting troubled about and wanting to block. Even though it literally can't get out of the browser sandbox, people still say, well, I'm just going to block it anyway. So a WebCL file is not a portable executable. It does not resemble one. It doesn't have the same kind of header shape. There's just no reason to imagine that it's more dangerous than like a text file or and it's going to be safer than something like a PNG because, it's not going to be parsed by native code that could have buffer overflows or something like that. So, it makes no sense for anybody to imagine that there's a rationale for blocking or being concerned about one of those files.
Well, that's good. Okay, yeah, I see it as more of a phantom menace, that people say, well, we're not going to use WebAssembly because some people have this problem. As you said, it's a total of like 5 people in the world. Yeah.
Yeah, I'm not promising it's that number. I'm
no,
sure
that but it's low.
Find more than 5, but as a sort of a fraction of the usage, it's rounding out. Well, smaller than that. It's almost almost non-existent.
Almost non-existent. All right. Has the team ever considered using gRPC for circuits instead of SignalR? And if what happened with those discussions, and why would you or wouldn't you?
Well, we started doing Blazor Server a long time before gRPC was a well-developed thing on .NET. So that's where we started. But I think even if we started today, SignalR would still be a better fit for this scenario.
Oh wow!
SignalR is designed around these mass usage at scale over long periods scenarios. gRPC is still a request-response-based system. It still assumes that your responses, even though they can stream for a while, are not going to be like very long running. Whereas SignalR, WebSockets, they are built for scenarios where the thing might be connected for hours and hours, maybe days. And also we have things like the Azure SignalR service that gives you a predictable and robust way of scaling to, tens or hundreds of thousands of concurrent users by automatically balancing load at the Azure network level so that you don't have concerns about, having too many connections to your server at the same time. So it's more well-developed for this kind of scenario than gRPC is.
That's good to hear. And I just want to remind everybody, maybe you can confirm this, there were some questions about, MAUI hybrid, like Blazor hybrid. Okay. It seems to me that this is a web thing. It's not, there are no changes to, Blazor hybrid because you're just using the component model, but you're on a machine, you're on a device.
Absolutely. Yeah. So Blazor is a UI programming model, and the components that you create are intended to work across all the different hosting environments. You can be as specific to a certain environment as you want, or as general across all of them as you want. And generally, by default, your components should work anywhere, whether it's MAUI on any of the operating systems and mobile devices that supports, or whether it's WebAssembly server, passively rendered server. That's the goal. Yep. It's one component model that can just run anywhere. So,
long story short, don't worry about MAUI. You don't have to do anything different. There's no server, client, whatever. You're just on a device. It doesn't apply to you. Nothing to see here.
Yeah, I mean, it just means, yes, there's nothing specifically new for MAUI, but also the problems that we're solving with Blazor United simply don't exist in MAUI anyway. Correct. So why would you want to?
Yeah. All right, that's all I got, Steve. This is great stuff, and I think I'm going to try pulling down the nightly build and giving it a go. I mean, even though it's nightly build, I'll try it.
All right.
Yeah.
I mean, it's only a prototype. It's not the real implementation, but have fun.
Yeah. All right. Thank you.
All right. You're welcome.
Blazor Train.